purpose of this video is for you to be able to state some key features of experimental design. One day, Crazy Hair asked Dr. Square what was on his mind. And Dr. Square told him that he had a bit of a problem in that he was wondering what type of sail would be the best for a sailboat. The variable is the name of his sailboat, the variable. So Crazy Hair said, well, let's solve that problem following the scientific method. And he said that's a really important feature. And when you do an experiment, it's best to sort of follow the scientific method. In that first thing is you have a problem. In this case, you want to know what sailboat is best, what sail is best for your sailboat. And Dr. Square said, what are you talking about, the scientific method? And Crazy Hair goes on to tell him, well, first step is that you have a question. In this case, it's a sailboat question about that you have. And then you do some research, and then you come up with a hypothesis, and then you're going to have an experiment to test your idea. Then you're going to analyze your results, and finally you're going to come to some sort of conclusion about your results. In this case, hopefully you'll have a better understanding of what type of sail works best for your sailboat. And oftentimes when you follow the scientific method, you end where you began. In that, you end with more questions about what it is that you're studying. So Dr. Square said, well, I guess I understand that the shape of a sail might determine its effectiveness. So how would I write a hypothesis about this? All right, so Crazy Hair says to Dr. Square that a hypothesis is basically set up in three parts. You've got an if, a then, and this is 'cause, or this is because. So those are like the three parts. The first part really talks about the independent variable, and it states what you're going to test in the experiment. What are you going to do? It's followed by the second part, which really is the prediction of the outcome of the experiment. If I vary this independent variable, then this will happen. So in the second part, you really talk about the dependent variable, how fast the sailboat's going to go. And the third part, you'd really write about your reasoning. You'd write about how you think green is going to be the best because you love it so much. Now, of course, Crazy Hair is thinking this is a bad reason, but this is just, Dr. Square is thinking this is a silly reason. However, it was Crazy Hair was just illustrating the form of what should go there. Now, Crazy Hair gets asked by Dr. Square, how would I set up my experiment? Well, Crazy Hair tells him there's some really... You would set up your experiment using some key factors. One is that you would test one variable at a time. All right? If you look here, Dr. Square has varied two things in this trial. He's varied the fact his mast, where the mast is. All right. He also varied that he had three sails in this boat. So he's varied two variables, the mast and the sails, and that's not really the best way to go about it. The second thing is you want reproducible results. So on this particular day, he decides to do it on a solar eclipse. And if that's not going to happen every day, then you kind of want to do your experiment on a day or in such a fashion such that you can get the same results every time. And everybody knows the moon is what kind of affects the tides and affects the ocean, so that's not the best time to be doing a sailing expedition. You're going to want a control, and a control is something that often lacks the independent variable so that you can compare your results to it. So in this case, he's experimenting without a sail to see how his boat does without a sail. And finally, you want to reduce error. You don't want to sail on like the worst day possible or in the strangest place possible, because you're not going to get consistent results. And it's going to be hard to know what is actually determining the speed of your boat.